the Smart Fitness machine. I am Gabriel Saintvil. This is Mohammed, Spence, and Khaled. Alright, we designed the machine with 6 different workouts and to incorporate a technological approach. Our motivations are to find new ways to have the user find a way to work out at home or in their privacy without going to the gym. And our project, well, our design is compact, durable, cost-effective for everyday users. And we use a simple user interface.
Other goals for our designer, for example, visual or audio feedback from the workouts, as well as to be able to track repetition and certain pace with components we'll be discussing shortly. Some constraints or considerations that we have to take into account for our design is we're trying to make it adjustable to fit as many heights of users as we can fit. We are trying to make it adjustable from the range of 4 foot 10 inches to 6 foot 6. We chose those numbers because according to the Center for Disease Control, as of 2007, 99% of the U.S. population would fall within that range. Another constraint that we are trying to set is the height when it's folded to be put away the machine, because one of our main goals is to make it easy to store. So ideally, we would like to keep that under a foot or about 30 centimeters, so it may be stored under most common beds or anything of that matter.
All right, so our global design, we want to increase the obesity, it's increasing both obesity rates. We want to go ahead and make sure that we lower those rates, because as you guys know now, like obesity rates have risen in the past couple of years. Most restaurants or new diets have come into the effect now within the years to go ahead and reduce these rates. And we want to be a part of that group, and we want to go ahead and make sure that our machine can actually promote the decrease of obesity rates. We also, for our global design, have worked with the International Health Racket and Sports Club Association. That's a health fitness group that's actually around the world, known around the world with within different countries. And technology. Technology is actually growing in a rapid rate right now, and we want to be incorporated within the growth of the technology. So just as Mohammed was saying and Gabe was saying earlier, we want to actually make the machine smart. And by making it smart, we're going to incorporate technology into our machine to make it smart. The design experience. So we just want to make this machine as compact as possible and portable for the use of the user. Like again, we want to make this as like a home gym, but you can carry it to the work environment as well too. We're going to innovate technology, like I just mentioned before. Just to kind of go in a little bit into it, we're going to actually add a monitor onto the machine to actually go ahead and.
Thank you, Patrick. Allow me to explain the design alternative and how we came up with the right fit to the market. By looking around the market, after looking around the market and doing a couple research by comparing the fitness machines designs, we found Flagler is one of the best fitness machines in the market because of one, it's like the lightweight of the machine because of the material it was made, which is make it easy to move around. Second, it is easy to store because of the size of the machine. And third, it's multi-muscle trainers. Flagler design gives you the opportunity for the trainer to exercise 6 different muscles by performing 6 different types of exercises, which is cycle, stepper, setup, push-up, arm exercise, and leg exercise. Even though Flagler have one of the best design in the market, but we can't ignore the issues in the design, which is uncomfortable for the arm and the feet because the size and the shape of the design is expensive because the material was made of the machine, and also it's unsuitable for everybody because it's made to the advanced trainers and only can be used for certain height, age, and body types. Also, is needed periodic maintenance is mandatory to keep it clean and can be used for a long period of time. So we came up, after we looking at the issues and tried to fix it, we came up with a solution to make it a better design, which is we made it as suitable. We made it suitable because by changing the size and the shape of the machine to suit and fit everybody, every type, body type and height. Also, we made it comfortable by adding the pads for the arm and the feet. And by changing the material of the machine, we made it heavy duty, easy to clean, and need low maintenance.
Okay, now to continue with the technology, this is pretty much what we're going to add on to the smart fitness machine. We want to add 4 sensors. This would actually go ahead and count repetitions and track the pace of the workout. We also want to incorporate sweat-resistant coating of IPX4. So in case there's heavy workouts, the sweat doesn't damage the machine as well. A rechargeable battery. This is also for the console itself. And for the console, we want to add visual feedback as well as data storage. And the speaker as well, this is going to be implanted onto the machine itself, and it's going to act as if it's a coach. So if you do the correct rep, it will go ahead and let you know, and also it incorporates a timer and a counter as well too for that workout.
Just some engineering analysis we have to conduct in the machine, of the frame of the machine. These are the forces that we experience while undergoing a sit-up exercise. We analyze the critical parts and use a safety factor of 1.5, although the loads and material properties are well known, just to guarantee everyone's safety. And we use a constant force of 2,000 newtons. We derive this from rounding the force of gravity to 10 meters per second squared and using a mass of 200 kilograms, which is more than anything the machine should experience. So if it can withstand that force, it should be safe. These are just some of the parts that will be analyzed. Depending on the geometry of the joint, different formulas will need to be used, depending if it's a spring joint or an adjustable bar. These bars are located on the side of the machine with different holes to adjust for the height. We chose to use a mild steel because it's a popular cheap steel used in engineering. It's easy to weld, and although it's not the strongest structural material, it's more than enough to fulfill this machine's requirements. It does have a weakness to corrosion, but that will be addressed with the sweat-resistant coating that Patrick mentioned. So the actual failure analysis we'll be conducting is for static stress first, comparing principal stresses to maximum allowable stresses. Just because it can withstand the static stress doesn't mean it will withstand the many loads and cycles of fatigue. So we have to test for that too, and we have to make sure the machine does not deflect too much for then the fittings and bearings to be incorrect. Also in the adjusting holes, we must check for stress concentration around the holes. If it fails with this design, we must adjust the diameter of the holes or the number of holes in the adjusting bars. Some future work that we have to do for this design, we can calibrate the sensors to auto-detect an exercise rather than having to input it to the console. We have to determine the best communication from the methods to the console and then out into the speaker as the feedback. We can make the data easily accessible for already existing third-party applications to further enrich the user's experience. We could design attachments such as resistance bands on the sides to add even more workouts, such as resistance for push-ups, extra resistance. And we have to design a kit version because kids are not meant to be trained with resistance, and this machine is specifically used with resistances, different interchangeable spring joints to adjust for different users. And that is the conclusion of our presentation. Any questions?
Comments, questions for the team?
Can you go back to your free body diagram, please? So that load of 2,000 pounds you assessed was at each individual section there you have pointed out?
Right, so we just use that as an arbitrary number, 2,000 newtons, because like I said, it's more than anything you should experience. So if it's deemed safe for that load, it should be safe for anything you'll experience during operation.
You use point loads?
Yes.
Did you think of any moment analysis?
Yeah, we used the shear force and bending moment diagrams to obtain the principal stresses.
Aren't you concerned that you're over designing this significantly?
How so?
I mean, like, top athletes can put down 350 pounds of force with their feet, like Formula 1 race car drivers when they push down a brake pedal.
Right.
Those guys are like elite athletes.
Right.
And if you're designing to 2,000 pounds plus a factor safety 1.5.
2,000 newtons.
Or sorry, 2,000 newtons plus a factor safety 1.5. It's a lot for like your regular person, because you just said that the previous design was meant for like a specific type of person. This seems like you're just over designing it.
No, it's supposed to be for anyone. That's why we would have interchangeable spring joints for adjustable resistances if you need a high resistance or a low resistance.
Okay. And what happens when your coating fails? Is this going to fail?
We were just people who
We just chose a rating of IPX4 because it's resistant to splashes of water. This really shouldn't come into contact with much water other than occasional sweat or if someone spills a water bottle. So it should be more than enough for design. We could increase the rating and it'll last longer.
I think it's more of a concern with like if you have this in South Florida, for example, and you're moving it and by mistake you hit something that's a little bit harder than that material, you remove the coating and now you have a huge corrosion risk to your machine that will lead to like really high stress concentrations in that area and then it'll break. And if you're doing something where you're putting down, 300 pounds of force, you're gonna seriously hurt somebody if like they're pushing down, like doing like a dip or something, and then one arm breaks, like that person's gonna probably dislocate a shoulder or do something like that. Like, I would probably revisit your material choice and like find a way to make sure that this will not fail under corrosion at all, because like no matter what you do, it will find a way to fail. So you want to do the best you can to make sure that doesn't happen.
The force adjustability question to me is important. So make sure when you do this work that you've designed it in a fashion that you have the ability to control how much force a person applies. Because if you're working over a whole different range of people, you want to be able to say that, I can put this much force into the system. Stored energy, make sure that, when you put the force to a spring that someone accidentally slips, they don't get hit in the face with a bar coming back. And fatigue, how are you going to measure fatigue? Let me ask that question.
We haven't started that analysis, it's just something we have to take into consideration.
But what are you thinking? What's your thought path?
Just run the iterations, so for, I don't know what an appropriate life would be for a machine like this. I would have to search that.
I would look at the industry standards. There's usually a very specific lifing that you would have to meet with these machines. So start there.
You should figure out what your endurance limit is for the materials you're using and make sure you never get close to it.
So you mentioned that you were thinking of a specific height. Have you thought of other dimensions? So not everyone is 2 feet wide. Not everyone
it definitely expands sideways as well. It has the adjusting hose there as well, but we haven't set a specific range for the width only because of that.
Okay, I would consider that also the weight of the person using it. So take those three into consideration. As far as the adjustability, did I see screws? Is that how are you adjusting the lengths?
The lengths, it's so the bar will have multiple holes and it'll have a pin just like any crutch.
And do you know what the weight of your current design is?
No.
So that goes a little bit with what you said earlier. if you're making this out of steel, you might want to consider how, is this gonna weigh 30 pounds to transport? Maybe there's other material choices you can use that target or that will eliminate your corrosion issue as well as transportation.
Yes.
Are you guys going to conduct any sort of testing on a prototype before you ideally launch this to market, or is it just going to be all analysis?
No, yeah, definitely we would like to build a prototype, attach all the technological components, and make sure they all communicate with each other accordingly, and that the frame withstands the loads.
How are you going to test it though? You're just going to put one person there, having them do a workout, or?
Do simulations or physical testing.
Okay, well, in my experience, simulations are as good as the person simulating. And if you make your simulation say what you want to say, it will close. It's really scary to see something that you think is supposed to work and then break, and then you have to figure out why. So if this is a mass consumer product, it would be really important to pretty much find out how this breaks, explain why, and then rationale why that would never happen to a person. You know, if you're putting 10,000 pounds of load on something like that, then you're fine, or 2,000 pounds, 2,000 newtons or something like that, and that's a reasonable number, then you're good. But, you know, your numbers are numbers that you could have a math error, and again, leads to like a catastrophic failure that's gonna hurt somebody.
I would take that a step further and not only look at what the machine can handle, but also the unexpected. Someone sitting on the bar, or someone, two people hanging off of it. You see crazy stuff like that with fitness products. Just people being creative in the way they are used. So I would also consider what are the unexpected things that you could potentially do with this machine, and see how you could avoid that from happening, or even how to design to expand on your product capability.
Thank you very much.